The red supergiant star located on Orion's shoulder has recently undergone a remarkable transformation. Its luminosity, or brightness, surged by over 50%, propelling it to become the seventh brightest star in our night sky. This sudden increase in brightness has left astronomers astounded and excited. You see, Betelgeuse is an aging star, nearing the end of its life. It is so massive that if we were to place it at the center of our solar system, it would extend as far as Jupiter's orbit. Scientists have long been monitoring Betelgeuse, as they know it is destined to go out with a cosmic bang in a spectacular supernova event. The significance of this brightness surge lies in the fact that it provides us with a unique opportunity to witness Betelgeuse's behavior in real time. It's like watching stellar evolution unfold before our very eyes. This surge has sparked a flurry of observations and analysis from astronomers around the world, eager to understand the underlying causes and implications. By studying this sudden increase in luminosity, scientists hope to gain insights into the internal dynamics of Betelgeuse, such as changes in its size, temperature, and atmospheric conditions. These observations could shed light on the mechanisms at play as a star approaches the end of its life cycle. A surface mass ejection is an incredibly rare occurrence, and Betelgeuse's SME took astronomers by surprise. To put it into perspective, this event expelled a mind-boggling 400 billion times more mass than a typical mass ejection on other stars, or even a coronal mass ejection, CME, on our own Sunday. This is equivalent to the mass of the moon, propelled outwards at incredible speeds. The sheer magnitude of this mass ejection highlights the uniqueness of Betelgeuse's behavior. It's a phenomenon that scientists had never directly observed before, and it provided them with an unprecedented opportunity to study a dying star's surface dynamics. So, what caused this awe-inspiring event? Scientists believe that an unusually hot current of gas, akin to a gigantic and scorching bubble, rose from within Betelgeuse. This upwelling of hot gas was triggered by the turbulent and convective nature of the star's envelope, where materials continuously mix and move. As this colossal bubble of hot gas ascended and broke through the star's surface, it resulted in the ejection of a massive amount of material. The expelled matter included molecules and dust, which partially obstructed our view of Betelgeuse and contributed to its apparent dimming. But the SME's impact extended beyond Betelgeuse's visible appearance. It caused the star to lose a significant amount of mass in a single event, far surpassing its annual mass loss due to stellar winds. Betelgeuse had blown off its metaphorical top and was now slowly recovering from the aftermath. This surface mass ejection not only showcased the raw power and intricacies of stellar dynamics, but also opened a new window for scientists to investigate how massive stars like Betelgeuse evolve and change over time. By studying the aftermath of this remarkable event, astronomers can gain valuable insights into the intricate processes occurring within the star's core and atmosphere. Betelgeuse, as a red supergiant star, is classified as a semi-regular variable star. This means that it experiences cycles of increasing and decreasing brightness due to changes in its size and temperature. Until recently, it was known to have two principal periods of light pulsation. The first period occurred every 400 days and was believed to be the result of pulsations in the fundamental mode. The second, longer period lasted approximately 5.6 years, but its origin remained unknown. With the emergence of the surface mass ejection, SME, event we discussed earlier, Betelgeuse's pulsation behavior has undergone a significant alteration. The star's surface kept expanding, even as the deeper regions of the star were contracting. This imbalance caused the star's pulsation period to shift from its usual 400-day cycle to a new, shorter period of 200 days. Astronomers believe that the unusual behavior of Betelgeuse's pulsation periods is linked to the aftermath of the surface mass ejection. The ejection of such an enormous mass and the subsequent changes in the star's size and atmospheric conditions have disrupted its regular pulsation pattern. Fear not, as this alteration is not expected to be permanent. Scientists anticipate that over the next 5 to 10 years, Betelgeuse's regular motions and internal dynamics will gradually restore its pulsation periods to their previous 400-day cycle. This restoration would align with what was considered the star's normal behavior before the surface mass ejection event occurred. Betelgeuse, a red supergiant star located approximately 650 light-years away, is approaching the end of its stellar journey. Based on its color, brightness, size, and estimated age, scientists suggest that Betelgeuse is still in the early stages of helium to carbon fusion, a process that needs to continue through oxygen, silicon, and finally iron before the star's core collapses under its own weight and triggers the cataclysmic explosion we know as a supernova. However, predicting the exact timing of Betelgeuse's supernova is a challenging task. Astronomers estimate that this spectacular event could happen anytime within the next 10,000 to 100,000 years. Given the vast timescales involved, it's highly improbable that we will witness the dramatic end of Betelgeuse during our lifetime. The occurrence of a supernova is influenced by various factors. As Betelgeuse continues its stellar evolution, the fusion processes in its core generate immense heat and pressure. These processes sustain the star against its own gravitational pull, but once the star exhausts its nuclear fuel, its core will no longer have the necessary energy to counteract gravity. Consequently, the core will collapse, leading to a powerful implosion followed by a violent explosion, an event that will release an extraordinary amount of energy and material into space. While the supernova of Betelgeuse is undoubtedly a cosmic spectacle, it also holds great significance for astronomers. When this event finally takes place, it will provide a remarkable opportunity for detailed observations and groundbreaking discoveries. Astronomers will be able to study the various stages of the explosion, from the initial flood of neutrinos washing over Earth, detectable by observatories worldwide, to the exponential brightening of Betelgeuse, potentially reaching up to 100,000 times its usual brightness over the course of a week. The supernova could even be visible during the day and cast sharp shadows at night, rivaling the brightness of the full moon. One of the remarkable aspects of Betelgeuse is that its surface is visible to us, unlike the interiors of most other stars. This visibility offers astronomers an unprecedented opportunity to study the intricate details and dynamics occurring on the surface of this massive star. By closely observing Betelgeuse's surface, scientists can unravel the complexities of stellar evolution and gain a deeper understanding of how massive stars age and eventually meet their cosmic fate. Through observations using powerful instruments like the Hubble Space Telescope and ground-based observatories, astronomers have been able to capture images and data that reveal the fascinating behavior of Betelgeuse. They have observed peculiar phenomena, such as the surface mass ejection, SME, that occurred, where an enormous amount of material was ejected from the star's surface, a phenomenon never seen before. Studying Betelgeuse's surface details has allowed astronomers to track the star's pulsation periods, uncovering changes in its pulsation rhythm. Previously pulsating every 400 days, Betelgeuse has transitioned to a new pulsation period of approximately 200 days. This alteration in pulsation provides valuable insights into the internal dynamics of the star, revealing how its size, temperature, and other factors are evolving over time. Additionally, observing Betelgeuse's surface enables scientists to study the effects of convective processes within the star. Like a boiling pot of soup, the star's convective envelope generates turbulent motions, causing the rise of hot gas bubbles from within. These convective processes can result in the ejection of stellar material and impact the star's regular pulsation patterns. The information gathered from studying Betelgeuse's surface and its peculiar behaviors contributes to our broader understanding of stellar evolution. By analyzing the data and comparing it with theoretical models, scientists can refine their understanding of how massive stars evolve, how they lose mass through events like SMEs, and how their pulsation periods change over time. This unique observational opportunity provided by Betelgeuse not only sheds light on the fascinating characteristics of this particular star, but also serves as a window into the behavior of other massive stars in the universe. By studying Betelgeuse, astronomers can gain crucial insights into the life cycles of massive stars, their final stages, and the formation of exotic remnants such as neutron stars or black holes. Betelgeuse's peculiarities continue to amaze and intrigue astronomers, providing us with a front-row seat to witness the wonders of the cosmos. Don't forget to subscribe to our channel for more mind-blowing celestial discoveries. Until next time, keep exploring the universe and keep looking up.